Okay. So I asked you to watch a video. What was covered in the video? Give some example of what was covered in the video. State chart. So what's a state chart?
It's a chart that maps the states of an individual.
Okay.
And how they interlink with
Aha. So it characterizes discrete states with respect to some particular classification, and it describes the evolution of those states over time. So it captures the state and behavior, as it were. And commonly it's applied at an individual level. But don't fool yourselves. Just because it's commonly applied in agents doesn't mean it has to be an agent. You could have a state chart in any logic in main. You could have it in the scenario definition, etc. So in general, there's not there's no rule that we can only use certain mechanisms in certain classes in any logic, certain of these sort of building blocks. So in short, a state chart will describe a decomposition with respect to some particular set of factors and behavior with respect to that decomposition over time. So I want to emphasize here that you can have multiple state charts for a person, or for whatever is being described. So one state chart might describe, for example, someone's progression among different age categories. Another state chart might describe, for example, someone's progression among, for diabetes and its complications. Another one might describe it for an infectious disease, say hepatitis C, and yet another might be applied to TB. Any number of different conditions. Another might be education level for that person, or employment status, going from full-time, from unemployed to full-time work to part-time, etc. So a state chart helps us sort of characterize possible states a person can be with respect to some factor or domain of interest. And they're modular, so we can have more than one, and they can interact indirectly by sending each other messages, or by setting a variable in one that the other one reads, or what have you. But for the most part, they evolve independently. And in its most simple form, if we consider, say, a given agent with a state chart, that given agent can be in exactly one state of that state chart at any given time, for the simplest case. And that is what's called the simplest state. We'll see that there can be hierarchical states as well, which can include multiple states in them, in which case you could conceptually be, I could be employed, and I could be employed full-time, for example. So there'd be an employed state, which includes full-time and part-time, and then a full-time, which is sort of a more specific state. But state charts describe the sort of evolution of discrete categories. So if a person's status with respect to these things evolves in a discrete way among a set of discrete categories, we might use a state chart. If you wanted to describe a person's evolution in a continuous fashion, how might you do it? Having a variable that varies continuously. You could do it with a function, yeah. So you could have the return over time, the value of a double precision value that's evolving in some arbitrary way. But we've seen mechanisms before in this class, in many lectures of the class, where we can have behavior over time with continuous state. Where did we see state evolving in a continuous way in this class?
Everything in Vensim.
Yeah, everything at Vensim. So all the stocks and flows at Vensim are describing the evolution of a continuous state, changing over time with stocks and flows. And it turns out that any logic allows you to put those in, associate those with an individual agent, for example. So you could have some things that evolve in a continuous way according to stocks and flows as well. Okay. But today our focus is on state charts. So, as Kurt noted, we have this decomposition into states. So it might be a susceptible and an affected state. Those are discrete states, they're discrete categories, and we have some means of evolving between them here in the form of a transition, one or more transitions. And last time we saw we had an entry point for the state chart as well, sort of distinguished entry point. Okay, so we have these transitions that go between states. Where do things happen here? So where is, so we may have some behavior over time, evolution between these states, etc. Where is their action? Where's their change occurring here? There's change, sorry? Yeah, there's transitions occurring, so the change occurs to go from this state to this other state. And it turns out that when you cross one of those transitions, you can trigger some action. When you enter a state or when you leave a state, when you come into the state chart, there's actions that can be triggered there. And we talk about there being a handler for that action. So there's an action here. We could specify some code if we want to that will execute, for example, when this transition is crossed, or that will execute when the state is reached. Okay? So we have these actions which can occur in conjunction with this evolution between states. Now let's talk, though, I mean, the core action, in some sense, that the most important type of action that's occurring over time is this transition between these states, going from one state to another. What sort of logic, what sort of rules are associated with that transition? What makes a transition happen? What sort of things can make a transition happen? Okay, so I'm hearing a whole Greek chorus. This is great. So I welcome the choral accompaniment. So I heard a time, I think. Can we make that more precise? Okay, there could be a rate. A time out. So some specific amount of time after entering that state. A rate. What does a rate mean? If I say I have a rate of 0.01, it's a chance per unit time, and therefore, if that's the only way I could leave a state is via transition with time 0.01, how long on average do I spend in that state? 1 over 0.01 or 100 time steps. It's the same basic logic we had when we had a first order delay, and we had a flow out, and the formula for the flow out was alpha times x, and we had some parameter alpha. This is a chance per unit time of leaving here, and it had a value of 0.01. Here we have a kind of similar situation, except now we're dealing conceptually with sort of the probability of remaining in this state changing over time. So it's sort of like the probability of remaining in this state over time at time t declines over time. Can anyone tell me the formula? E to the minus alpha times t. If alpha is 0, what is this probability of remaining in that state is 1. As alpha grows larger, the probability goes down in an exponential sort of way, and it's this sort of familiar pattern. Right? That's if we have a fixed time constant. Okay. So here we have something that conceptually is quite similar to our first order delay. Here we, in a way, it's the first order delay associated with probabilities. But here, ladies and gentlemen, the transition's occurring at a certain point in time. So this is our chance of remaining. Whether or not we're in there is a dichotomous thing. We either are or we're not in this state, remaining in this state at a given time. This is our chance of remaining there. given time, but this is a stochastic model. We leave at a specific time, right? Okay. So that's good. So that's a rate transition. What's a timeout transition? If I were to draw a comparable figure for a timeout, so maybe this is time. This is time here. I should have labeled it. This is probability to remain in the state. This is time. Maybe alpha is 0.1, and so our mean time in the state is 10, so something like that. 10. Okay. This is 1 over e. But so that's the value of that variable at that mean time is 1 over e. It's e to the minus. This and this will cancel, so e to the minus 1 over e. Right? Okay, so that's good. So that was for the rate. So this is a rate transition. Rate transition. This sort of declining curve. Kurt, remind me to get these in my slides. Okay, similar graphs. So what if I drew this for the probability of remaining in the same sort of way? Probability to remain in the state. If I drew that for a timeout transition with a timeout of 10, what would it look like? What would that look like? It's 1 and then it's 0. So at time 10 is when the transition occurs, exactly, right? What other sorts of transitions are there? Okay, message transition. When I receive a message, say from another agent or from this own agent telling themselves kind of, hey, do something, buddy. Do something to themselves. It could happen. So there's a message received. That could trigger a transition. How about another one? Condition. So I might transition when a stock, the value of my stock goes to a certain level. So my level of viremia goes to a certain level. I have this many virus particles in my body, and I transition to a death state. Okay, so that could be a trigger based on a condition. It's the condition of a variable or some other call function determines the condition is true. Okay, so that's good. What other types of transitions? There's one more I have in mind. Sorry? Timeout, yes. So that was this one. We're definitely in the state until that time, and then we're not at all. But there's actually another one, and it's okay. So we could have a variable, right? You're right. That would be a rate transition, but the rate constant alpha is changing over time. So maybe I'm more and more likely to leave the longer I'm there. Instead of being memoryless, I just have a certain chance per unit time of leaving the state. Instead, I have a greater and greater chance, for example, per unit time of leaving the state. Maybe we're considering your chance of developing kidney disease after you get a diabetes. There's a certain chance per year early on, but the more longer you've had it, the more damage is done to the kidneys, and therefore the more and more likely you are per year to get it. That can happen. So that's good, but it turns out we do that with the normal rate transition. We just have that rate constant change, the rate changing over time. So that's good. It would need to be sort of told about it in some sense that, hey, your constant's changed. Go update it. But it would be we do it with the same thing. Well, it turns out the other one is an arrival transition. When you've arrived at your destination. So if you're moving, it gets woken up and say, hey, you got to your destination. And that's useful. That's often useful if you're having agents moving about. I thought we might use it last time, but we... Whoa, there's a... Oh, thank you. Thank you. I should have my glasses on before I try something this ambitious. Okay. Wow. The people on YouTube will wonder what's going on. Okay. There we go. Okay, so those are the types of transitions. So, ladies and gentlemen, let's illustrate this. Okay? So, fire up your AnyLogic and let us compute. So we're going to do something really trivial here. We're just going to exercise some of our standard skills in a way that illustrates this. Some of you may have already done this and may want to play around with some other things. So I'm going to create a new model, File, New Model, right? And I'm going to create a model called Statechart Example, something like that. Statechart Example. Statechart Example. Okay. And I think I'm going to, well, I was going to put it somewhere nice, but I'll do that afterwards. Okay, here's our Statechart example. Okay, ladies and gentlemen, so I want you to tell me, rehearsing basics here. We're rehearsing the fundamentals. So here's my Statechart example. I want to make it so that we have agents that appear on the screen, and we're going to do it such that when they appear, they, depending on, we're going to add a state chart. Well, so we're going to have it so that periodically they change their state over time, and their color will depend on the state that they're in. Their color will depend on the state that they're in. So, and we want them to be in two possible states. We want them to appear on the screen as an oval. So tell me what to do. I just created this model. What do I do? Sorry? Okay. That sounds like a okay, so here's a shape thing. What do I have to do before that, though? Okay, I need to add an agent class, right? So we want to do new active object class, and sure, we'll call it a person. For sure. Well, not to say the person's the only one. So I have to turn into an agent. How do I do that? Click on agent under general. Okay, fine. So how do I associate this person with a visualization? Okay, good. So with this presentation, let's draw an oval and let's put it around them. Okay. So that's fine. Yes. No, you could. There. This is a good question. We could change the scale and so on. I think you can change the color. Okay, you want to try color? Let's do a picture. Let's just see what happens, okay? Okay, I'm going to get rid of this oval. Okay, no harm done. And let's go down to these pictures. Last time we had the nurse. This time should we try the doctor? Okay.
Can we do a truck so it's gender neutral?
Okay, you want a truck? Okay. Okay. Yeah. I prefer, since this is a person, it would be better if it were, I think, an icon look a little bit like a person. Okay. So here's our person. Now, if we wanted to check whether we could specify the color for this, where would we go? Dynamic as a property of this, and you'll notice there's things you can control here, but there's nothing. Sorry, no color. It looks like color. It looks like is absent, which is too bad. It's funny because I thought for some of them there was actually. Oh, is that right? This one? Okay, that's what I must remember. Okay, so I just dragged generic person, and you think there's, sorry? Okay, but so Kurt, you thought you saw it?
Well, not this time. I did before.
Yeah, I thought so too. I mean, it's kind of a curious. It doesn't seem to be there. Yeah, so I'm I'm sort of drawing a blank with that. So I think if we want to do color, it may be best to do the oval for now. I know what it is. Okay. Okay, this is a good chance to teach this lesson. Right. Okay. So let me put back the doctor. Some of you may still have the doctor there. So there she is at the origin, and if we go and we look at what the doctor actually is, we can go expand person, and we can find a consistent presentation. Then it says doctor, and you'll notice it consists actually of various pieces. This doctor is composed of pieces, and the pieces consist of a set of components like polylines on the one hand, or curves, etc. So if we go look, for example, at polyline here, we can go to dynamic properties of polyline, and you'll notice that there's a fill color here. You see that? Do folks see that? It actually is composed of pieces which can be colored. Okay? So, in other words, what we think of as kind of a monolithic thing is actually composed of pieces, and those individual pieces enjoy coloring ability. You'll notice the line color for these curves can also be colored. So here we have this ability to sort of color different pieces of it, and it looks like different components cover different parts of a doctor. So if we really want to find out which part covered which, you could see this one covers kind of their bib, this one sort of parts of their head, etc. So if we really want to color them using this, we would we'd have to choose which part. I'm going to choose PS20 because it kind of looks like it goes around here. Okay, so it goes around the central area, PS20. Okay. Okay, so ladies and gentlemen, I've just added this kind of depiction to this agent. Suppose we were to run this model. Would we see a population of agents? Okay, what do we have to do to have a population of agents? Sorry? Okay, we need, to show them visually. It turns out we'll need an environment. But what else do we do more fundamentally than an environment? Yeah, we need a population of people, even more fundamentally. So we can drag person over to main, and that's our population. That will depict our population. It's just a kind of shortcut way to sort of say, hey, we have a population. Another way you could do it is through this menu on the right with agent population, okay? And you'll notice now that it gives us a set of choices. The most important one is to say replicated, and maybe we'll make as a parameter, we've seen that before, a thing called total population, or we could call it, sure, we could say total population, and that will be a count of the number of people in the population, or maybe it should be, count, population count. And then we'll have the population. So ladies and gentlemen, we just added a parameter called total population. I really dislike that name. That name makes sense in other contexts, but I think I'll call it population size, maybe, or population population count, population size. Okay, I'll call it population size here. So I drag this parameter in. I call population size, then I made it an integer because it's a discrete quantity, 0, 1, 2, 3, 4, 5, etc. Right? And then we'll have the population size depend on the number of people. Where do I specify that for population? Remind me? Okay, so I want to have this population, the number of people in the population be whatever the value of this parameter is. Where do I specify that? And this replicated has to be checked, and I have to specify in this initial number of objects. Okay? So population size. Okay? Is that okay? Okay. And what's the final thing if we want to have them appear visually? Environment. We need an environment so sort of how big the area is over which they should appear, etc. So we dragged in an environment from the general, right? And we'll leave its name as environment, and we'll go to the advanced properties to go see, okay, this is a continuous 2D space. It's not divided into a grid. Later we'll see grids, okay? Okay, so that's great. And then we can have this population depend on the environment. How do we associate that environment with the population? We specified an environment here, all right? Okay? Okay? So, ladies and gentlemen, is that enough to get them displayed? Let's run it. Let's go see, okay? So it's building it, it's turning it into something it can execute, and here it's displaying it. Where are they? Where are they? No, I actually don't need to do that because I created the presentation before I dragged them in. What's the problem here? There's a very simple problem. Okay, so who specifies, I'm trying to make a point here, who specifies the population size? Okay, so if a person had a parameter, who would specify the value of that parameter? Main. It's actually the population in main in which that person is enclosed. If you have so it's the thing that creates that person. If I have a parameter in main, who specifies that parameter value? Who creates main? The simulation, the scenario that creates it. So if I go to simulation, you notice there's a parameters here and population sizes under that. Okay? So that's the scenario. That specifies what assumptions to run this model. Okay? So it's 100. Yeah? I'll make it there. Yes. Okay, so I didn't specify one when I gave it, but maybe you specified one. That default value, that would be the one used if I didn't fill it in. Okay? It's actually just an expression, and if you didn't fill it in here, it would use that expression.
We can use population size here.
So you're saying in the population size parameter, you're saying there's where it says you could specify 100 there, and that would be the default size. You could specify 1,000, but that's just if it's not specified. That's what it would be.
You can use a variable there. Yeah.
Yes, you could. Yeah. You just have to be sure that that variable is initialized when you use it. Okay, so ladies and gentlemen, actually, so Farhad is asked a bit of a subtle question. You could use a variable. You have to make sure where the variable lives. I could talk with you offline about this, okay? Because that will be substituted in as the value wherever it's. So it would need to be something that the scenario knows about, that variable. Okay. So let's run this now, and there's our population. Okay. Okay. So ladies and gentlemen, that's great. We have a population. I'm trying to rehearse these skills, build these skills, right? Okay, so now how do we associate people with some state that changes over time between two discrete states? So suppose we wanted people to go between a state of being employed and unemployed. Sorry? Okay, so let's go to person. So you write to say it lives in person. So how do we add a state? A state chart entry point. We do that. Okay, so this will be called, I don't know, employment state chart, something like that, right? I'll zoom out a bit. Employment state chart. That will be my employment state chart. Maybe I'll have a different one for my education, a different one for my this has gotten kind of yeah, there we go. Okay, and what do I do? So this is my state chart entry point. What do I do now to add states? Okay, so I drag a state over here. Great. So I'm going to have an unemployed state, unemployed state, and an employed state, right? Sorry? I did it with capital, but I would just have a clear convention whether you do capitalization or not for your model. Like if, in other words, think a little bit, do you prefer them with lowercase or uppercase? I happen to do it with uppercase. And then employed, something like that. Among other things, it's I think an uppercase gives it a sense. It's not merely a variable name. Okay, and that's great. So I have two states. I just drag them there. Now, suppose I want people to go between them. What do I do? Okay, transition. So I could pull a transition in to go from unemployed to employed. Let's leave that with the default semantics. And then suppose to go back from employed to unemployed, I can drag back the other way. Now, it's important you recognize, and I think I talked about this in the video, it's important you recognize the coloration of this. So if it's a disconnected end, it'll be white here, but when it's connected, it'll be, so this is telling me, this would be connected here if I let go of the mouse. I let go, that part's connected, and then I can drag this over here, and then that's connected. But, if it's a near miss, it's something like this, it may look from a distance like it's connected, but it's not. It needs to be green, okay? So we'll leave that like that. Okay, so that's great. Now, ladies and gentlemen, what happens if I run this model now? Is anything happening? Well, okay, so is something happening? Is there dynamics associated with it? Let's go look at population member. Are they changing? Okay, whoa. Are they changing over time? Okay, they are. They're going back and forth between unemployed and employed, right? So there actually is something, yes. Sorry, make it upside. How can you, you mean how can you make it going up like that? So I think what you're asking is like, if I dragged it in, let me drag this in again. If I dragged it in here, how can you make it upside down? So you would just drag this handle over to here. And just as a note for those who will be needing to route these around things, you can double click on these, and that gives more handles. And then you can, drag it so it kind of goes in a more graceful way, or what have you. There's also ways to delete those by double clicking on them. Okay, that can be nuggetized. Okay, so and notice, by the way, these transitions could be named. So we could call this, securing job transition or something like that, and this could be called losing job transition or something like that, if we want to name them, to use them elsewhere to find out properties about them. Okay, so there is dynamics going on. Is it visible? If we look at the broad thing, no, it's not visible. So how could we have it? This is a bit of memory. How could we have it so that people's color depends on their employment status? Okay. So we'll add colors. Indeed. Sorry. Let me. So we're not disturbed by another cantata. I'll turn it off. How could we make it so that their color depends on their employment status? Yes, so we could, one way to do it would be, okay, but let's take the big picture. So we want their color to depend on their status. What would set their color? Well, okay. What would be the mechanism by which if we wanted them to appear in a certain color, where would we specify that now? We want them to appear black. Where would we specify it? Okay, yeah, it was in that presentation. That's why we were talking about it. So I'd say, PS20. So let's, just as a proof of concept, for PS20, for their fill color, let's set it to be black. What do you think? Is that okay? Okay. Okay. So where did I go for that? I went to the person, because there's an aspect of a person, and it has to do with their presentation, right? It's their color. I mean, it's not their logic, it's their color. And I went in, and it turns out doctor as a whole doesn't have a color, but the pieces of the doctor do. And this part is kind of the doctor's belly. I mean, for lack of a better term, it's kind of their belly. So I'm saying it here for their fill color. I'm not positive about whether that's going to give us the desired feature, but let's give it a try. I'm going to set all the doctors to have a black color. Okay, so let's run this. All right. Sorry. Okay, so now we have doctors with oh, it's kind of like their tunic, or scrubs. Okay, so by the way, I scrolled in by doing Control click in here. So you do this to scroll in, for example, or I thought you could do it with this other way, but I guess not. So you could sort of scroll in and out. Okay, so that does control the color. Okay, so that's great. We know how to control the color. Now, how do we set it? So suppose now we want the color to change depending on the state they're in. I'd like you folks to suggest to me 2 different ways to do it. We can start with the first one that comes up. So what was it? Good, good. So how do we do that? Okay, we could use a function. Now that is a fine idea, young man. That's a beautiful idea, and I will put my enthusiasm behind that. So we could use a function that's called something like color for state or something like that, and it'll return a color, and then we'll use that color. That's a great idea. So can we create a function like that? How do we create a function? Well, we drag it from general color for state or something like that. Now, the beauty of doing it this way, I salute Farhad for his observation, because the beauty of doing it this way is it's robust to changes in, for example, the vagaries of which state charts you have or which particular states you have. That's all encapsulated. So if you want to use the color here, use it there, know what it is, you just call this function. All you have to do is change the function to update these things. You don't have to go find wherever it's used in all these different places. It's all in one place. Okay, so color for state. Okay, so now we have a function. What does the function return? It actually returns a color. And to have the return, so let's be more specific than that. It returns a reference to a color object. But informally we say it returns a color. Okay, so the return type, is it void? Is it Boolean? No, it is other, and it is color as spelled by way south of the border. You have to give it a big C. Why do you have to give it a big C? It's a class name. It's the name of the color class. In other words, we're saying we're returning a reference to an object of this type, of this class color. In other words, there's kind of this class describes colorness, and we're returning a reference to what's almost like a pointer to or something. It says, hey, it's that color, that particular color. Okay. Here, this is like the cookie cutter, and it's the cookie cutter mold, and we're saying, okay, it's one of the cookies created by this cookie cutter mold. The color class is like the cookie cutter mold, and one of the things created by it is the objects of type color. So this returns a color thing. Now, what do we put in for the body of this function. Okay, now the chickens come home to roost.
We need to have a way of accessing which state they are.
Okay. Okay, good. Let's suppose we want to test this first. Remember, build incrementally. Test it, make sure it's working. Let's suppose we wanted all the person's tunics to be, all those scrubs, their upper scrubs to be black like it is now. What do we return here? Black. Okay, black. And what do we have to go have it depend on color for state? Where do we do that? Sorry? Well, okay, but wait a minute. If we just want to, so we're building on the Farhad idea of having a color for state, but first we want to test it just returning a single color. Okay? Where do we have it use this information? Who uses it? Presentation. Okay, Kurt was raising his hand. Do you want to see flocking behavior? So were you going to suggest something though? Okay. So.
I have a question about the flocking.
Okay, yeah. There's a better way to do flocking. I thought about. Oh man. Shortly after class, I said, "Oh man, I should have done this." It's very close, but it would have been cleaner. Okay, so now we have to fill color. What do we put instead of black? Yeah, we call color for state, and we do a call of it. Ladies and gentlemen, is this a function or a statement? Is its job to compute a value, or is its job just to kind of do something, to change something? It computes a value, so we don't need a semicolon. Eh? Does that make sense to people? It's computing a value. It's just like 3. Or if we had 2 plus 2, or if we had, if this thing is greater than that, do this, return this, otherwise return that. Okay, so we have color for state. Okay, let's run it. Let's make sure it works, right? Okay, so run this thing. Okay, great. Fantastic. So that works, ladies and gentlemen. Now let's deal with the chickens. The chickens are coming home to roost. How are we going to return a color based on the state that they're in? Okay, we need some way of knowing which state they're in, right? Someone uttered that before. Who would know what state they're in? Who would know here? Would this presentation know what state they're in? Would Maine know what state they're in? Who knows what state a given person is in? Okay, the person knows, but what part of the person? The state chart, the employment state chart. We need to ask the employment state chart. Okay, so ladies and gentlemen, let's go look at what employment state chart suggests. Okay, so we have employment state chart. I did control space, and then I do dot. I'm asking it for something. Okay, and here you'll notice that there's something called get active simple state. So we could use that. We could actually get it to return for us the name of the state that it's in. Eh? That would be one way to do it. Otherwise, we could ask, is state active, and give it a state, and that will return something saying, hey, am I in this state? Eh? Okay. Now, there's people from many backgrounds in this class, and I'm torn between my desire for generality and software engineering beauty versus my desire to use statements that are very, very simple. I think I'll err on the side of simplicity here because I erred on a different side during last lecture. I threw caution to the wind and now regret it. So I'm gonna ask here this is state active. Okay, I'm gonna use this is state active. So I'm gonna say if is state active unemployed. So that's my state name, unemployed. If that state is active, I will return red. Otherwise, I'll return black. Okay? Okay? How would you do this if you, how could you do this for an arbitrary number of states? You could have else if, else if, else if, and so on. But what would be a nicer way to do it? Use a switch and case statement. You'd say, get active state, get the name of the active state, and then I'd do a case. Case this, case that, case that. If it's a, if I'm in this state, return this one. If I'm in that other state, return that other one. We'll come back to that. But I want to get people comfortable. Are people comfortable with this note? So this is if employment state chart. Why is it employment state chart? Because we're asking the employment state chart, hey, is your state active called unemployed? If so, return red. Otherwise, return black. And by the way, there's two hidden parentheses over here that are just occluded by the palette here. By the way, I'll make this minimize it so you can see that here, and I'll show you how you can maximize it. And then it will pop back. Okay, just like that. Pop back. Okay. Okay. So, does that code? Are people comfortable with that code? We're asking the unemployment state chart, hey, is this state of yours active? If so, we'll return red, otherwise black. Okay, ladies and gentlemen, let's run this simulation. What should we see? Changing color. Okay, how should they be changing color? It's a timeout. Okay, so there we go. I could speed it up, and you could kind of see it's kind of firefly-like. Or like crickets, all chirping at once. Okay, so it's like a Christmas tree. Yeah, I think that was in the video. Is that what had in the video? Where I said it was like a Christmas tree? I've used that one before. Normally I do it with red and green. Okay, so that's great. So why are they all blinking at once? Give me the semantics. Why? Yeah. Yeah. It's an exact time after they enter the state. Exactly one time unit after they enter the state, they leave it via this. Exactly one time unit after they enter this state, they leave it. Okay, so if I wanted to break that fearful symmetry, how could I do that? I could make it a rate transition. I could leave the same rate, but ladies and gentlemen, or will they now be in synchrony? Okay, so now we'll see something like this instead. Stochastics Rule, indeed. Their recovery takes exactly one time unit, but they've been desynchronized by when they get. So, you know, now their time in that state is decaying just like a first order delay. They have some chance of being there, and it's actually distributed how long they're there. Okay. Okay. So, ladies and gentlemen, here we have this situation where we're illustrating state chart dynamics through this. So we're illustrating the fact that these different mechanisms for transitioning, for governing, for gating these transitions do have implications, and we can see it quite visually. Okay. Now, ladies and gentlemen, because it's a teachable moment, I'd like to change to add a state that's going to be called retired. Okay? Okay? Okay. So, how would I do that? Okay, add the state here, and it's going to be a retired state. Okay? And someone might retire either from being employment or being unemployed. Being unemployed, it would sort of be like they say, well, look, you know, I'm not finding a job. I'm gonna retire for the rest of my life. Well, I mean, this does happen, unfortunately, and particularly for older workers, you know, they at some point they give up looking. Actually, it's a little bit of a scandalous statistic. The unemployment rate does not include people who give up looking for work. So So when you say the unemployment rate is 17%, it's often much worse than that because a bunch of people have given up work looking, and it doesn't count those people anymore, which is, it hides a big problem sometimes, particularly during big recessions like we've recently come from. So here we have a retired state. That's great. So
Could that be a final state?
it could be, but great question. We could have a final state, and I'd like to introduce that later. Sure, we could have that be a final state. That would make sense, but I want to teach this other thing. Okay? But it could be a final state because we never leave it. Another distinguishing feature of a final state is that can be shared between multiple state charts. One of these guys, one of these normal states, it's only normally in one state or another state chart. A final state can be shared between state charts, and it might represent something like someone's death or something like that. Okay, but let's look at retired. Okay, what has to be changed now if we want to have them in the retired state be green? Okay, color for state. Okay, now there's two ways we can handle this. We can do an else if, you know, this, else. But I'd like to show you the switch in case. I think it deserves learning. Just, okay, if I have these three things, one thing I could do is, I could, instead of using isStateActive, I could do switch, employment state chart dot, and I can do get active simple state to get the sort of the name of the current state that's active. It's actually sort of the ID of it. And then inside the switch, I could have case unemployed, okay? And then I can return, for example, red. Case employed, I can return black. And case, maybe I'll change that now so that when they're employed it's green. It's kind of like, okay, they're in a good state. In case retired, I can return black. Okay, so they're kind of no longer between the two. Okay, and really to be robust, I should really have a default. Maybe I changed the state chart and I forgot to update this function, and I could do something here that triggers an error. Okay, so I could say, for example, assert false. Okay. In other words, I say that, okay, something bad has happened. Okay, so and then it forces me to actually return something here. So I just have to satisfy it that it needs something there. Fine. But this assert will say basically it will throw an error. If I ever get here, it will say, look, I don't know what's going on, and it will alert the modeler. It'll alert them, says, hey, my assumption has been violated. So, ladies and gentlemen, this is good practice because it helps guard against, if you ever forget to change this code, you've added another state, it will remind you basically by handling this case. Okay, that's good software engineering. But those folks not from computer science background or haven't had a lot of use with C-level languages, this switch statement is a very nice way of handling many cases in a compact fashion. Okay, and it's an alternative here to an if. You could have if, else if, else if, else if, but this is kind of cleaner. Yes?
You were just returning red, black, green, something like that.
Yep.
Do we need to define these things? These are the instance of object class color.
Correct. Yeah, it actually knows. So those are part of what AnyLogic has as standard imports. So it imports the library that's used to define color, and these are defined as part of that. So it knows these constants because it imported that library as a standard thing. Sorry? Yes. Then you could say color.green, but you don't have to. Yeah. Yeah. It's a good question, but in this case there's no clash. Okay. Okay. So okay. So now we should be able to run this, and we should be able to see people evolve over time, and everyone retired. Okay, they were. Yes, exactly. I just had a default timeout. So tell me where to go. It's good you folks found that. So after 1 year, one time unit, yes, which could be a year. Exactly. So let's make this. Okay. So what should it be? Maybe they have a certain chance per year of retiring.
You can give it a condition and say what.
Or,
age, so
yeah, exactly. Exactly. So, ladies and gentlemen, if we wanted to have a way to keep track of their age, how could we do it? There's actually many ways in any logic to keep track of age. Sorry? Okay, we could do it as a parameter, but then they won't age over time we'd have to modify that, keep on modifying that parameter. How else could we capture age using something we've seen already? Give me 2 ways to capture age. One continuous, one discrete. Start with the discrete one. How can we capture things that change among a set of discrete categories? A state chart. Okay, does it have to be big?
Continuous is nicer because it's always smaller than it.
Okay, I too am a lover of the continuum, but we're going to start somewhere. So here's the age state chart, and so I'm going to actually drag in. So I just created an age state chart. This is emphasized we get multiple state charts at the same time. So I'm going to drag in here something called so I'll just call it working age, and then I'll have, retirement age or something like that, and I will have a transition between them that occurs at what age? 65, for example. Okay, so it occurs at exactly age 65. Does that make sense? Okay. Okay, now, ladies and gentlemen, we could actually here have. Well, tell me. Actually, this is a good subtle lesson. So why do I have to add that state chart? Why can't I just say this is 65? After 65 years, they go to a retired state, and I'll make it the same here. After 65 years, they go to a retired state.
You could run it and then show that it never happened.
That is the right way to do it, Kurt. I admire your pedagogic insight. Okay, so let's do that. Let's do that. So I could see a nugget being formed. Okay, so now we're running this model. Where are the retired people? Okay. So yes, we don't get there. We could have print out something when this crosses. They never get there. Why don't they get there? After all, it says go here after 65 time units. It says go here if they're here, they go after 65. If they're here, they go after 65. What's wrong with my reasoning? Okay, I am getting the intuition. What does this 65 mean? Yeah, it's 65 years after entering the employment state, they'll go here. Now, what happens before that, almost with certainty? They change to unemployed. And when they're unemployed, they go here. Okay. So there's 2 ways we could deal with this. So there's 2 ways to deal with this. One way is we could create another state chart like we've done.
Could you make it a rate?
Well, we could make it a rate, but then we'd have people when they're off, there'd be youngins and they're still retiring.
But we could give it instead of a rate, maybe we could improve by giving a distribution function.
Yeah, we'd have to keep track of how long they've been there and that sort of stuff. But it's more mechanism. Yes, you could do something like that. But ladies and gentlemen, another way we could do it is by having a separate state chart. They go to retirement. And then, ladies and gentlemen, what you could have is this be a condition. You could do it based on a condition of being in that state of post-working age. In other words, retirement. They go to retired, okay? That would be one way. Another way, you could do it based on a message, and what happens is when they go this way, it sends this other state chart a message. It says, hey, you retire now. And then they retire. Who wants to see the first way? Who wants to see the second way? The message? Okay. So we go down here, and so we're going to send this other state chart a message. Okay. This is sort of give hints. It's a premonition of our next class. Okay. So we're going to send a message to whom? To whom do we send the message? To the employment state chart. So we're going to do employment state chart dot. Okay, and we'll do. Hey, oh man, send to. Is that the name of it? Receive message, I think it is actually. Is there a separate send to? No, it turns out, well, for a state chart, you could just say receive message such and such. Okay, receive message retire. Okay, so how did I do that? Let me. By the way, double click on a tab. Here it is, full screen. Right? Employment state chart dot receive message retire. So here we're telling the employment state chart, hey, retire. We're saying, you know, I'm sending you a message, and if it's in a state right now where there's a handler for a message transition, which is affected by a message like this, it will leave via that. Okay? So where is this occurring? This is occurring when they reach that age of 65 years. It's going to notify this other state chart, hey, you should retire. Now, what do we have to do to complete the loop? Complete the handling. When it receives this message, someone has to handle it. So this one, instead of just being a timeout of 65 years, becomes a message transition. And in this case, I only have one message, so I'm just going to do it. And it goes this way. So it's unconditional based on receiving a message. It goes from here to here. Does that make sense? And similarly, this guy goes from here to here based on receiving this message. Does that make sense to people? So here we have two message transitions. Let me make these properties obvious. So here there's this transition. It used to say go after time 65 exactly, but we never reached that point in this unstable economy. So here it travels based when it receives a message unconditionally, not even checking what the message says. And at that point, the transition will fire. We don't need to perform an action. Okay, can we try this? Ladies and gentlemen, let us compute. So, so we're going to go try this now. So we will we'll go and run this, and you'll notice time is ticking on. Time is ticking on here. Ladies and gentlemen, oh, they all retired. Did you see that? Okay, people missed it, I think. Okay, ready? Watch this. Oh, boom. Look at that. Did you see that? Okay, I'll slow it down so you can see it better. Okay, here we go. Oh, switch to there. Okay, watch this time. Okay, ready? I'm gonna. Oh no, I want to go a few more years. Okay. Ooh, okay, they're getting on there. Okay, watch this. They're approaching. Okay, they're in their 60s now. Watch this. Okay, and now they're hitting 65. Boom. Did you see that? Okay, so they retired. So that's one way to do it. between state charts. Okay, so this would be like multi-state chart retirement model, and I'll save it as such and I'll share it by popular demand. Multi state chart retirement model. But ladies and gentlemen, there's a nicer way to do it in this case. Okay. Okay. So the nicer way to do it, if that were all of our concern, if we didn't need to otherwise care about this state chart, one thing I could do is I could get rid of this state chart. If that was the only reason we have to do it, turns out there's a better way, ladies and gentlemen. And that is to do with a hierarchical state chart. That's what makes this a nice little teaching example. Okay, so, yes. Okay, so, sure. Kurt's also approaching from behind. So. Okay, can I check this? So let's check. Okay, so Farhad had this question. Okay. Oh, okay. So you want to run it? What does anyone retire after age 65? Oh, you're saying this doesn't appear here? Okay. Save this. I just want to do a sanity check. Can you close this model and then open it again? Okay. Is it this one? Okay. And I'd like to build it. I should build it, and I'd like to run it. Okay. There's still okay. 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 That's very interesting. That's extremely interesting. Okay. I'm tempted to close any logic, reopen any logic, but it just strikes me as very strange that it's not. So it isn't. Were there problems? No. No. Okay. Okay. Can you modify something else and see if it complies? Okay. I'm going to come back to this. I want to work this out. Okay. But that's very strange. Okay, ladies and gentlemen. So to complete this lesson, we're going to be using a hierarchical state chart. What I mean by that is a state chart where one state contains another, where we can have states that are not mutually exclusive and collectively exhaustive. In other words, that you're in one and only one state, but instead you can be in a state which represents also a collection of substates. You can be in one of the set of substates. So I'm going to create a state, ladies and gentlemen, that's called here. Yes. Yes. We'll say that again. Start them at different ages? Yes, we could. Wonderful question. That's actually an insightful question. Because, and it's one that's a little bit textured when it comes to state charts. Okay, so last time we saw, trying to give context to your picture, last time we saw that we could easily introduce heterogeneity, a population where people differ with respect to income, differ with respect to the location, etc., right? Now, what you're really asking about is how do we make people differ sort of in terms of like how old they are initially, right? Well, okay, it was an age thing, but I got rid of it. Or differ maybe in terms of where they start here. And one thing we can do to have them, some people we could have start unemployed, some people we could have start employed, for example, okay? That would be a starting point. But I think if we want to start people at different ages, that would be a bit of a problem for that other state chart, because after all, exactly 65 time units after entering, they leave by that transition. But we could break the working age transition, state into multiple states, and then have them go. Some go to older states, some go to younger. And how would we do that? Well, we could do that with the branch transition. In fact, I'm sorely tempted to do this right now. Okay, so would you mind if I introduced it so some people start unemployed, some people start employed, and then you could figure out, you could see from that how they might start at different ages, for example, if you had states for different ages. Okay. Later we'll see a very clever mechanism by which you can start people at continuous age. Okay, they can have exact ages, but the point remains, like, how do we start them kind of off at different points? Okay, so ladies and gentlemen, how are we going to start them? Some start employed, some start non-employed. Well, gosh, this is just so nuggetable. I'm going to